One of the main points of our climate discourse here is that there should be money and effort devoted to both heat and cold events to come, while currently the study is somewhat one-sided. When it comes to cold climate events, we look to cosmic rays, and I came across this article again recently and remembered my initial reaction to it. Of course not. They cause global cooling. You see, their initial idea was that cosmic rays produce clouds, which is true, and we're told that the greenhouse effect, like on Venus, would take effect here and heat us tremendously. However, it turns out that albedo is a more powerful actor, the reflectivity of our planet, and our white cloud tops reflect a great deal of light. The science on cosmic ray cloud formation is growing mature. As it does so, the effect on cloud formation is found to be surprisingly correlated with solar activity. In fact, during a CME impact, after a solar flare or filament eruption, we notice a drop in cosmic rays as the cloud of plasma surrounds our planet, geomagnetic storms on the inside, extra electromagnetic material around the outside, blocking further outside electromagnetic radiation from the galaxy. Solar activity can explain a recent questionable point in cosmic ray cloud formation. The recent weak solar minimum had record low cloud formation associated with it, which is surprising because we should have seen record high cosmic rays. However, we had a solar flare 2 years after the last solar maximum that was larger than most of the flares of the last 2 cycles. Another larger than anything we've yet recorded during this cycle. Furthermore, the coronal holes refused to sit in their polar position for the minimum sunspot cycle and created multiple magnetic storms and created their intensified current sheet effect in the solar wind particles. Their Alphen waves played a role, the ultra-hot plasma emitted played a role, and so did the open magnetic field lines extending into space, bolstering the heliosphere. Even in the blankest sunspot years, we were not wholly without space weather. So if we're worried about cold and indicating that albedo will play the important role as the sun weakens further, we're clearly focused on cosmic rays increasing soon. Indeed, this is the hint as solar activity heads downward. According to our observational history, Earth has seen X20 or higher solar flares in each of the last 2 sunspot cycles, and should see about 8 X10 flares during the maximum. We have not yet seen one this cycle. We should have about 175 X-class solar flares per cycle, but this round, as of June 2014, we've had less than 30. The weakness of the current cycle makes one question how much of a decrease in cosmic rays this sunspot maximum has actually offered us, and given the historical inverse relationship between solar activity and cosmic rays, could we be in for significant cosmic ray events if we indeed enter an extended minimum or grand minimum solar cycle? Some of the most respected names in solar science not only recognize the weak current cycle, but the potential for the sun to take a multi-decade nap, as it does every few hundred years, as it did 400 years ago. One author predicted this back in 2010, and makes a terrific case for coming global famine and harsh winters soon. Landscheid predicted it even earlier, and we are seeing more and more hypotheses of impending ice from some of the most respected sources. We even have Intellicast offering a quasi-what-if hinting that we are due for a drop in solar activity. You'll recognize this chart as the same one that shows how high solar activity was during the time of global warming. The fact is that we need to study and plan for extreme heat and tropical events, drought and flood, but also the colder aspects of this climate destabilization, including its encroachment into growing seasons. Surely, some farmers in the U.S. at this point have lamented delays or struggles in recent yields caused by cold. What happens when there's frost and snow in late June in Oklahoma? Where do we reconcile the Venus greenhouse issue with all these clouds? Well, there are many ideas, some as simple as the reflective properties we mentioned earlier. At all times, Venus is covered in clouds. There is no surface visibility, but the clouds are not white, a yellowish, brownish, and not entirely reflective of light like Earth's white clouds. Furthermore, when we have a lack of clouds here on Earth, sunlight is exposed to blue and green and brown, inviting more energy intake. Is that too simple? Perhaps. The better question and better point has been made already. Climate change is real. We can't pretend our projections have been perfect. But to right the ship, we must include the external effects.